Welcome to the lesson on what causes wind. In this video, we'll be focusing on sea and land breezes. The great thing about this lesson is that it draws upon each of the units we've covered so far this year. The main areas will include heat transfer, differential heating, density, convection, and air pressure. So let's get started and break some wind. Now the first thing we're going to need is a source of energy. So we're going to go ahead and put the sun right up there in the sky. Now, one thing we've learned about the way the sun heats the earth is that it does not heat the earth evenly. The earth's surface is made up of many different types of materials, and we have investigated how it heats four main earth materials. That would be sand, soil, air, and water. And most of those are going to come into play in this animation. First of all, let's go ahead and get a land source. And we're also going to need a water source. So we're going to go ahead and put the sea out there on the right-hand side. Now, we have learned from our investigation that land, which would be like sand or soil, heats up faster than water. Water has a higher heat capacity, so it takes longer to heat up. So in the course of a day, the land will be hotter than the sea. And you can always refer back to a life experience. If you've ever gone to the beach and you've walked across that hot sand, and as soon as you get to the water's temperature is much different than the beach temperatures. So that would mean by conduction, the air over the land would be warmer than the air over the sea. So warm air is right over the land, cool air right over the sea. Now, instantaneously, you should see that we have two different temperatures of air. And from prior knowledge, we've learned about density. And warm air does things differently than cool air particles. Warm air particles become less dense, and less dense particles will float or rise into the atmosphere. And oppositely, cool air becomes more dense and will sink. So you're going to have warm rising air over the land, but you will have cool air sinking over the ocean, or in this case labeled the sea. All right. Already at this glance, you should see a convection cell has formed. All right, a convection cell is essentially a cycle of moving air. And we're trying to prove and understand what causes wind. Well, we just got it already. It's right there. But let's add a few more components just to kind of tie this all together in a wonderful package. Since warm air is leaving the area over the land, that would create less pressure on the land. You see how the arrow is going away from the land? That would take air particles away. Therefore, there'd be less pressure pushing down on the land. But if you look over on the right-hand side where the cool air is sinking, and that arrow is drawing air particles down and pushing on the sea. That creates two different areas of pressure. That means low pressure is existing over the land, again, because the warm air is leaving that spot. And across the sea, there's an area of high pressure. That air is sinking and pushing down on that area over the sea. There you've got it. The rule is high pressure air always moves towards low pressure air. Air will move wherever there's a space. And since there's been a space created over the land, air will gradually just naturally push its way over there. And that's what wind is. When air is being moved in large quantities across the surface or in the atmosphere. So since we have a high pressure area over the sea, a low pressure area over the land, the rule is high pressure air always moves towards low pressure air. And now we have a movement, wind, moving from the sea over to the land. We name it a sea breeze because the rule is you name a breeze or a wind by where it originated from, where it came from. In other words, where is the high pressure? In this case, because the high pressure is over the sea and the air is coming towards the land, we name it a sea breeze. And you can see the collection of all your previous instruction kind of pulling together into this picture. So, there we have a sea breeze, but there's also such a thing as a land breeze. In order for a land breeze to work, the pressure over the land would have to be higher than over the sea. The entire cycle would have to go the complete opposite direction. But based on our picture, how is that possible? So I'm going to take a moment here and think about it, and the video is going to be paused for just a second and have a discussion. What factor would need to change in order for this cycle to go the other direction? In order for the wind to go the other direction, one important factor had to change, and that is it had to happen at night. The reason why it has to happen at night for the cycle to go the other direction is again linked back to our investigation when we heated the earth materials. After we turned off the heat lamp, we allowed the materials to cool off, and we noticed that the land substances, the sand and the soil, drop temperatures much more quickly than the water. That's because water has a high heat capacity. Not only does it take more energy for it to heat up, once it does heat up, it takes a lot of time, a lot of energy for it to cool off. Therefore, it will remain warmer longer, but the land temperatures will drop quicker. And that's the only factor that had to change. So, since that happens, and at night the land would be cooler than the sea temperatures, by conduction, we would have two different temperature air. Warm air would be over the sea, and cool air would now be over the land. You can see already that's enough to cause the cycle to go the other direction. Warm air rises, and cool air sinks. And just as before, if warm air is leaving an area, that area has less pressure than it did before. Which then, of course, also means that as cold air is sinking over an area, more pressure is added to that area, because you can see the arrow is pushing down over the land now. So now, high pressure over the land. And of course, high pressure air always moves towards low pressure air. So now we have not a sea breeze, because it's not originating from the sea. The high pressure is now over the land. And since the air is moving across the land toward the sea, it's called a land breeze. Well, that's the entire picture. So the next time you wonder how wind forms, you'll be able to blow right through it.